Hello, I'm Sienna Bose. Welcome to my channel, Learning Balanced Life, and today we're going to talk about numerical problems and parallel equivalent resistors. In our previous episode, we have talked about a similar kind of a numerical, so you can go watch that as a refresher before viewing this one. Now we can begin. I'm reading the question before we can start. Three resistors of resistances 30 ohms, 15 ohms, and 10 ohms are connected in parallel to a 20 volts battery. Calculate the equivalent resistance of the circuit, the total current for the circuit, and the current flowing through each resistor. Okay, let's understand the circuit diagram very well. Here we have 30 ohms for R1, 15 ohms for R2, and R3 is 10 ohms. We have three resistors with resistances that we have considered as R1, R2, and R3, and their values are given too. We have potential difference of the source, or across the two common ends of these three resistors, AB, as 20 volts, and finally, the total electric current as I. Now we can begin. So first we need to find the equivalent resistance of the circuit, and as you can recall, from features of equivalent resistance, when the resistors are connected in parallel, then we got a special relationship, which we are going to use now. And we are considering equivalent resistance as Rp. So, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now we can substitute the values and do it very easily. Equal to 1 by R1 was 30 ohms plus R2 was 15 ohms plus R3 was 10 ohms. Getting the LCM as 30, we can write 1 by Rp equal to 30 by 1 plus 2 plus 3 equal to 6 by 30. Cancel out, we get 5 equal to 1 by 5. Or Rp equal to 5. Now that we got equivalent resistance, we can move on to getting the total electric current flowing through the circuit. So I'm erasing the board so that we can move on to our next part of the sum. Now, if you can recall from Ohm's law, we had derived V equal to I into R, and now we are considering that Rp, the equivalent resistance, has already replaced these three resistors. Let's do that mentally, the mental replacement of resistors with resistances R1, R2, and R3 with Rp. If we do that, then the relation from Ohm's law becomes like V equal to I into Rp. We are going to use this relationship to get I. Here we have V as 20, or now we can substitute the values and do it. Into Rp we got as 5 ohms. 5. Or, very simple, just I equal to 20 by 5 equal to 4. I equal to 4 amperes. We've got the total electric current in the circuit. Now finally, we need to get the current flowing through each resistor. So I'm erasing the board so that we can move on to that. Now, since in a parallel circuit the electric current gets divided, we will consider the electric current flowing through each of the resistors as some value. Like through R1 we are considering I1 is flowing. Through R2, I2 is flowing. And through R3, I3 is flowing. Let's consider it like this. Now, we know that voltage, that means potential difference, is not getting divided over here. Instead, the electric current is getting divided. Hence, I consider three fractional segments, which we have to get separately. And that's what's asked over here. So we have V equal to I1 into R1 because we know the relationship in Ohm's law that we have discussed about. We got I1 and R1 over here. Through R1, I1 is flowing. Hence, for the first one, we have V equal to I1 into R1 because this is associated with R1. And here I1 is the one thing we need to get. And V was not getting divided, so it stays the same. Or 20 equal to I1 into R1 was 30 volts, 30 ohms. Or I1 equal to 20 by 30. Very simple. Just cancel out these zeros and you get 2 by 3. 2 by 3 amperes. First. Second, with association with R2, same thing. Or 20 equal to I2 into R2 is 15 ohms. Or I2 equal to 21, 15. Cancel it out and we get 4 by 3. We are not doing this into decimals because it gives, here in this case it gives recurring decimals, and here also, since I've done fraction here, I'm leaving a fraction over here too. 4 by 3 amperes. And finally, our last one, R3, in association with R3. I3 into R3, or 20 equal to I3 into R3 is 10 ohms. Or, this is very straightforward. 20 by 10 equal to 2. I3 is 2 amperes. So we have got the values of each of these fractional I1, I2, and I3 flowing through R1, R2, and R3 respectively. And just a note, if you reevaluate, then you get 2 by 3 plus 4 by 3 plus 2 amperes together as 4 amperes. That was the total electric current flowing through this circuit. So I'm giving you a few moments to look at the board so that you can sharpen your concept. Hope you enjoyed solving this problem with me, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.